Hey guys, welcome back to another video. So in this one, we're going to try and solve this forces physics problem, yeah? So I handpicked this one and I think this is a great one. So let's check it out, guys, yeah? So we have a picture with mass 8 kg is suspended from a hook, okay? Calculate the tension force T in the string. So we're talking about these T's right up there. Now they want us to use the gravitational constant value of 9.81. So let's stick with that. Now, first things first, I always like to re-illustrate this and make it look a lot easier for myself. So for forces, first things first, let's imagine this whole picture as one long bar, yeah? So not as a picture. So we're going to imagine a long bar like that. And now you're going to copy out those T's, but let's not stick them together like they did. So let's put a T like one T over here. And we stick another T over here. Now the really cool things about resultant forces is that all you need to do is literally find the endpoint of these vector lines and just put like dotted lines going upwards. So what I do, I just circle them, and I always do like a dotted line going upwards on that side and one over here. Now the reason why we do this is because we will always want to make sure that this dotted line is always perpendicular to the ground, so it's always at 90 degrees. Now let's look at angle second, yeah? So we know that the angle at the bottom was 50 degrees here, and also 50 degrees here, which is convenient. That means the angle up here to make 90 must be 40. Now the trick is, guys, when you do forces, you always need to use sine and coses for angles. But with me, you're only going to use cosine, yeah? So you're never going to use sine, ever. Trust me, it's much easier that way. Now, looking at the rest of the forces, we also have a downward force of mg. We know the mass is 8, so m is 8. That means we could just go right down and just call it 8. And we know the g value is 9.81, so 8 times 9.81. We could put that in a calculator and get the result. Now, let's have a look. What we want to do is that firstly, we want to resolve vertically, yeah? So up and down. So what I always do, I always put this arrow telling us the direction of the positive values, and I put this V, meaning vertical. Now, all we're going to do is we're going to stick to a casual formula. We should always remember F equals ma, yeah? This is the classical force equals mass times acceleration. Because we're resolving vertically, we're going to change this F to all the vertical forces times mass times all the acceleration going upwards or downwards. Now let's have a look keyword, the acceleration. We know that the picture is suspended. Suspended means it ain't moving. If it's not moving, the acceleration is 0. So A is 0. So the vertical force, the vertical acceleration is 0. Now, let's work out FV first. So all the vertical forces, we got both T's going up. If you look at the first T, the way I calculate, if you want to follow this dotted line, this would be T cos 40. That's it. That's how it works. We always use the cos close to the angle. So because we use cos, cos works with the adjacent. So we just use cos. So it'll be T cos 40 for the first one, plus, if you look at the second force going upwards, it's next to 40 degrees. So it'll be another T cos 40. That's it. And now the downward forces are negative. The only downward force we have is 8 times 9.81, and in the calculator that gives us exactly 78.48 newtons. And that's it. And all of that is going to equal your mass, which is 8. So we just look at the formula, mass times the acceleration, which is 0. And that's it, guys. Now all you want to do literally is just finish it off and make T the subject. So what I usually do, I just collect these two together. So combine these two, you get 2 lots of T cos 40s equals, and then you got 8 times 0, which is nothing. Move the negative 78.48 across, becomes plus 78.48. And now all you want to do is divide that by 2 cos 40. So let's do that. When you do that, make sure your answer's in degrees, yeah? So you're going to have, therefore, T equals 51.2 newtons. And that's it, guys. You are literally done. You know, that's all you have to do. That's how we calculate everything, yeah? So other than that, I'll see you guys next time.